CompletableFuture is a class in Java that allows you to work with asynchronous tasks and handle their results. It provides a powerful way to perform operations in the background, enabling you to create chains of asynchronous tasks, handle errors, and combine results efficiently. CompletableFuture is a key component in modern Java development for building responsive and efficient applications that leverage the power of asynchronous processing. CompletableFuture in Java provides a number of basic methods to handle asynchronous operations. Here are some of these basic methods and how to use them. supplyAsync allows you to run an asynchronous operation that returns a result. runAsync runs an asynchronous operation without returning a result. Handle allows you to process the result or handle an error in one function. thenApply allows processing the result of an asynchronous operation. Expects the result of the previous operation and transforms it using a function. thenAccept allows the result of an asynchronous operation to be processed, but does not return a new result. thenRun is used to perform a specific operation that does not have access to the result of the previous asynchronous operation. CompletableFuture is a versatile tool used in production JVM applications to handle asynchronous operations. It allows for parallel execution, boosting performance in web services, data processing, and external API communication. Additionally, it's employed for efficient database access, file processing, and microservices collaboration. CompletableFuture enables resource management and effective handling of timeouts and errors, along with asynchronous stream data processing. It is an incredibly valuable tool in creating responsive and efficient JVM applications. Using CompletableFuture in Spring controllers aims to avoid blocking the server threads and to efficiently manage the available threads. This relates to the concept of managing a thread pool. When a controller returns a CompletableFuture, the asynchronous operation is executed in a separate thread or a thread pool provided by the server. This allows for the continued processing of other requests on the main server thread, increasing the application's responsiveness. In the case of high load and multiple concurrent requests, using your own thread pool, example, configured in Spring, is important to avoid depleting the server's available threads and maintain the application's stability.